My name is Vincent, and now we will be talking about the applications of carbon nanotubes. First application are nanoelectronic devices. The carbon nanotubes allow one fabrication of devices using nanometric scale. They can be used in projects of wide range of electronic devices such as diodes, transistors, and etc. Second is hydrogen storage. Nanotubes have been in lengthy development process as potentially useful material for hydrogen storage for fuel cells. However, there has been a lot of controversy regarding the claims of high hydrogen storage levels that have been shown to be incorrect, which deems it to be not effective as storage devices. Next is sensors and probes. Nanotubes, electronics transport, and thermal power are very sensitive to substances that affect the amount of injected charge. Chemical sensor of non-metallic nanotubes. Great potential for state-of-the-art sensor applications. Let's go with the potential and under development applications of carbon nanotubes. First is body armor. The University of Cambridge has developed a new type of high-strength and lightweight fiber from carbon nanotubes, which has promising application for body armor to be used for the military or the police. These fibers can be woven as a cloth and can be incorporated into composite materials to produce a super strong product. In addition to the very high strength of this material, the carbon nanotube fibers are able to absorb and distribute the impact that it does. These fibers synthesize with a hydrocarbon material such as ethanol alongside an iron-based catalyst are sent to a furnace. The hydrocarbon breaks down into its hydrogen and carbon atoms, and then the free carbon binds to the particle of the catalyst in the form of a long nanotube. However, this method is currently under investigations to be upgraded to industrial scale, because even though this product is very efficient, it lacks the research and technology as of now. The US Army are looking into this project to use these fibers for newer applications such as high-tech smart cloth or bomb-proof refuse bins. That is all for my presentation for today. Thank you and goodbye. Bye-bye.
Buddy, I see you're interested in carbon nanotubes. Well, carbon nanotubes are allotropes of carbon with a cylindrical nanostructure. The smallest have a diameter of close to 1 nanometer, and that places them right between the size of a molecule of water and glucose. They got their name after long hollow structure with the walls formed by one atom thick sheets of carbon called graphene. These sheets are rolled at specific and discrete angles, and the combination of the rolling angle and radius decides the nanotube's conductive properties. Individual nanotubes naturally align themselves into ropes held together by van der Waals forces, more specifically p-stacking. The chemical bonding of nanotubes is composed entirely of sp2 bonds, similar to those of graphite. These bonds, which are stronger than the sp3 bonds found in diamond, provide nanotubes with their unique strength. Nanotubes are categorized as single-walled nanotubes and multi-walled nanotubes. Single-walled nanotubes have only one layer of graphene, and multi-walled nanotubes have two or more layers of graphene. Multi-walled are therefore more resistant to surface modifications. Like everything else in nature, nanotubes also have so-called freaks, or in other words, unique forms. Those are torus, nanobot, p-pot, nitrogen-doped, and many other carbon nanotubes. They all have different structures, which usually results in enhanced electrical conductivity. Synthesis of carbon nanotubes is complicated, but there is more than one method on how to do it. All of them depend on graphite, which is sublimated using lasers, plasma, or arc discharge, and then cooled down so that nanotubes can form. With carbon nanotubes, even the sky isn't the limit. Because they are so light, a space elevator with a ribbon-like cable anchored to the surface and extending into space is possible. On the end that is reaching in outer space, there would be a counterweight making the elevator stable and allowing the climber to rise safely. It would be very useful for space explorations and maybe even tourism. Radar is a detection system which sends out radio waves. When the radio waves hit an object, they bounce back and are detected by the detector. The detector then determines the location of the object. However, if an object would be covered with multi-volt carbon nanotubes, it would be stealthed to radar, because the carbon nanotubes would absorb the incoming radio waves. Now that would be perfect for military operations. Imagine a world without cancer. Well, nanotubes could be the answer. Conscious cancer therapy uses single-volt carbon nanotubes, which are inserted around cancerous cells and then excited with radio waves, which causes them to heat up and kill the surrounding cells. Another way to remove cancerous tissue would be by building a nanochip out of nanotubes, programming it and then inserting it into nanobots. Because of their strength and ability to stop smaller projectiles, nanotubes could be used as a body armor for future soldiers. The armor would also monitor soldiers' condition and increase his abilities. The idea was already used in a video game called Crisis, which makes us one step closer to the real thing. In the future, people will be tempted whether to exchange the old organic arm with a bionic one, made out of nanotube muscles which can expand 4000 times faster than the human muscles do and can withstand extreme temperatures. The contraction of nanotube muscles is already possible by applying a voltage across the width of the nanotube ribbon. This makes them repel one another, and the ribbon can expand sideways up to 3 times its original width in an instant.